welcome. This is the first introductory lesson on smart contracts on the Ethereum blockchain. It will be a rather boring lesson in which I will talk blah 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 about how does the Ethereum blockchain work without giving you any practical example, which is pretty unusual for my lessons. Therefore, I put also my face. Can you see me? Haha. So you can get distracted a little bit. Okay. If you want, I can put it larger until I don't need it. Okay. First thing we will have to talk is we'll build smart contract and deploy them. Deploy means put a smart contract into something where it will work. It means more or less sign, propose. I can't make any comparison with real life contract. So we'll write smart contract and deploy them on the Ethereum blockchain. So we have to talk a little bit about the Ethereum blockchain. Well, I take for granted that you have already attended the lesson on cryptocurrencies or watched the video, so you know how does the Bitcoin blockchain work. The Ethereum blockchain is very similar. It has some little differences. Well, the first one, there is a confirmation each approximately 15 seconds. So it's much faster for the confirmation. The second confirmation is that the Ethereum blockchain is called Ethereum and doesn't use bitcoins for fees, but uses Ether. Ether. That's right. I have to shrink my face. Make it larger. So it uses Ethereum. Ethereum is the name of the blockchain of the network, and Ether is the name of the currency, abbreviated with ETH. Why do ETH? Ether. Okay. The smart, exactly as for the Bitcoin blockchain, you can make financial transactions, so move Ether from an account to another one. But you can do something else on the Ethereum blockchain. You can set up a smart contract. A smart contract is a sort of little program which is put on the blockchain, stays there. It's usually under the control of but not always, under the control of its creator, okay, and waits. Okay, people make call or transaction towards the account of the program, the smart contract account, and the smart contract behaves as it was programmed. So it's a sort of automatic program which stays on the blockchain. What are the advantages? Well, first of all, it's decentralized. So it doesn't run on a single server. It runs on every blockchain. So every blockchain has a copy of your contract. It's immutable. Even the creator can't change it. This could represent also a problem. It's unstoppable. Nobody can stop the smart contract from doing what it should do. Obviously, if it does things which comply with the rules of the blockchain. So even if the creator makes a mistake and sends all his money around, well, it can't be stopped. The smart contract runs. Okay, it runs without any third party or interface, and there is no downtime. Whenever somebody sends a request to the smart contract, it reacts within the confirmation time. So within 10-20 seconds, the smart contract reacts. But the most important aspect is that it's immutable, okay, and unstoppable. This is what makes the smart contract very different from the standard business contract, which can be changed by a judge or by the two parts involved, okay, and can be stopped by an authority or by the parts involved. The smart contract can't, unless it's written in the smart contract that one of the actors can change something or can stop it. But otherwise, the smart contract by itself can't be stopped. Okay. Ethereum blockchain, exactly like the Bitcoin blockchain, is pretty huge. Okay. So usually there are around the world some Ethereum full nodes which have loaded the entire blockchain, and some Ethereum, and most of the other ones are Ethereum light nodes, like the wallets that you have seen for my Bitcoin examples, in which you don't load the entire blockchain, but you load only that part of the blockchain which is relevant for you. So we will use in this course MetaMask, which is an Ethereum light node basically, so you load only that part of the blockchain. We will not use the real Ethereum network for this course. Why? Well, because we will need to pay fees to have the smart contract running. Well, and I can't ask you to pay to attend to do the course. We use the Rinkeby blockchain, which is an Ethereum test blockchain. So it's a blockchain identical to the Ethereum one, but which is only for testing purposes. So let's see. Okay. This is the Rinkeby test blockchain. This is Etherscan. It's a little website which let you check what's happening. No, I don't want this advertisement, thank you. We let you check what's happening on the blockchain. Well, if you put Rinkeby in front of it, you check what's happening on the testing blockchain and not on the real one. Well, the main advantage of the Rinkeby blockchain is that you don't pay to get the Ether from there. You got them for free. We will see during the course how can you easily get 15 Ether for free, which would require you to spend $2,000 or if you get the real Ether. Okay, so let's talk about an Ethereum account. Okay. We distinguish two different types of account. The first one is the EOA account, externally owned account. It's an account that a person, an organization, whoever owns. Okay. It's controlled by a private key, exactly like the Bitcoin account. You can send and receive transaction, okay, and you can have Ether on this account. This works exactly like the Bitcoin account. The other one is the contract account. Okay. The contract account also can hold Ether, so the contract can have some Ethereum in his hands. Pretty strange for a contract. Imagine a standard paper contract can have some money. Sometimes it happens, but can have some money inside the contract on the paper waiting there. Okay, can send and receive transaction. Okay, but never does it by itself. So the contract account never does something by itself. You have always to activate it, sending a message, a transaction. Otherwise, it doesn't activate alone. So it can send and receive money around, but it does it only if you activate it, and obviously if it is programmed to do so. Okay, and it's not controlled by a private key. So the contract account doesn't have the private key, so you cannot control it. It's controlled only by the code written there. So once the contract is deployed, it means it's put on the blockchain, you will never have control over it. That's the contract, that's what it will do. Okay. I think we have, let me see whether we have some, okay, the address of the accounts. Okay, the address of your EOA account, externally owned account. It's not exactly the public key as for Bitcoin, but it's derived from your public key. So you take the public key, it's derived from your public key, you get the address. Okay, well, it doesn't change anything for you. Okay, the only important thing is that it's not exactly your public key. The address of a contract account, on the other hand, it's a little different. It's derived from your public key, and so let's see, address for EOA derived from your public key. Okay, for contract, it's derived from your public key, so the public key of the person who deploys the contract, means so the person who puts the contract on the blockchain, and from the nonce. What is the nonce? The nonce, I think it's spelled nonce. The nonce, it's a number which tells you how many transactions have you made. Seems strange. So you have your address and this number which counts how many transactions you have made. Okay, Since deploying a contract, so putting a contract on the blockchain, is a transaction, suppose you have done 20 transactions, the 21st is putting the contract on the blockchain, so the address of the contract will be derived from your public key and the number 21, combined in a strange mathematical way, and will generate the contract address. The next contract you deploy, imagine you deploy another contract immediately after, will have an address which is derived from your public key again, and 22. Okay? So this guarantees that every time you put a contract on the blockchain, it has a different address. If it were derived only from your public key, every contract you put will have the same address, which is not nice. So deriving from the address and from the nonce, this magic number which is associated to each account guarantees that your contract has a unique address. Every time you deploy a new contract, it has a unique address. Okay, let's talk about Ether now. As I told you before, the Ether is the money on the Ethereum blockchain. Okay, one Ether currently it's worth approximately $170. Okay, one Ether has 10 to the power of 18 Wei. Okay, it's a unit of measure. So one Ether can be subdivided in 1 followed by 18 zeros. Wait, let's do it because so you understand better. 1, 2, 3, 4, 5, 6. Let's put also some spaces. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So one Ether is equal to this amount of Wei. I tell you because very often you find prices expressed in Wei, especially prices for fees. Okay, so don't worry, if you put 1000 Wei, it's not a huge amount of money. Even though we won't use real Ether, it's not a huge amount of money. Okay. Sometimes you find the giga Wei. So one Ether is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 giga Wei. Okay. So we have these subunits, like the Bitcoin has the Satoshi, the Ether has the Wei and the giga Wei. Okay. I tell you because very often you find the indication of the fees in Weis or giga Weis. Okay, let's talk about a concept which doesn't exist for Bitcoin, the gas. Okay. Whenever you do something with a smart contract, it may be deploying, so putting it on the blockchain. It may be some other operation, such as sending a transaction to a contract to activate it. So whenever you do things like that, you're using the computational power of other people. Because the contract is a program, so you're asking other people to execute that program, and you're using their computational power. To avoid that some people put incredibly difficult program to solve and destroy the computational power of the other node of the network, you have to pay gas whenever you do something with a contract, whenever you deploy it, or whenever you send a transaction to a contract. So any operation that you do on the Ethereum blockchain, so deploying a contract, even sending a transaction to a contract, so activating it somehow, needs to spend some gas. Okay. The gas can be looked somehow as the fee, but it's not exactly the fee of the Bitcoin blockchain. The gas, it's the amount of computational power necessary. Sometimes you can estimate well in advance how much gas do you need. For example, to deploy a contract, I think it's something around 35,000 gas. 35,000 units of gas to deploy a contract. Okay, there is a certain price for each thing you do. A multiplication in your code requires some gas. Okay, do you use some memory on the blockchain? Requires some gas. Do you do a loop? Requires a lot of gas. So every operation, there is a little table with all the gas prices. Okay. Most of the time, however, you are unable to estimate in advance how much gas your program uses. So whenever you submit a transaction to the Ethereum blockchain, you will simply write the maximum amount of gas that you are willing to pay. Okay? Usually put it very high. It's just a limit in case your program runs into a never-ending loop. Okay? so you have a limit and you won't spend more than that, then your program will be executed, some gas will be used, and any remaining gas will be returned to you, so don't worry. Okay. So whenever you send a transaction or deploy a contract, which is a transaction by the way, you will need to specify this gas, the maximum gas that you're willing to pay. You send it much higher than what is necessary. For example, deploying a contract, I think it's 36,000. You can set 100,000, doesn't matter. Okay, it's just a safety measure in case your program for any reason goes into a never-ending loop and uses all the gas. So you have a limit above which you don't spend anymore. Okay. Okay, what happens in case the gas that you set is not enough? In case the gas that you set is not enough, goodbye, you have spent the gas and nothing happens. So this is the reason why put it high. Not too high, but put it high enough. So be sure that the gas that you send is enough for your program to be executed. Just to give you, here I have some notes. Create a new contract, 32,000 gas. Make an addition inside your program, 3 gas. Make a multiplication, 5 gas, because it's much more difficult. Okay. Send just either from an account to another one is 21,000 gas. Put one number on the blockchain, or just one number, 1,200 gas. Okay. But how do you pay with this gas? Well, the gas is just a unit of measure of how many resources are you using. You multiply by the gas by the price of gas. You can imagine the gas as the gasoline station where you have to fuel your tank. Same thing. The price. You decide how much are you going to pay, the price of gas. The wallet with which we will do this transaction will suggest a nice price of gas. Okay. The higher the price of gas you put, the earlier your transaction will be confirmed. So this is the fee that you have in the Bitcoin blockchain. Imagine in the Bitcoin blockchain you have a gas always of 1 because you don't have any contract to be executed, any operation to be executed, so it's fixed. And what you set is the price of gas, which is your fee. Okay. Here, instead you set the price of gas and then you have this is the difficulty of your contract and this is how much are you willing to pay per each unit of gas. Don't worry, the program will suggest the wallet that we will use will suggest the price of gas. Okay, we will put always a high price because we are going to use Rinkeby, so we don't pay. But if you will ever pay, choose whatever you want. So don't choose a too high price, neither a too small price. So this is the fee of the Bitcoin blockchain multiplied by the complexity of the program that you are trying to execute. Because obviously, if I'm trying to execute a very complex program, the miner will have a lot of problem executing it, checking it. Okay, this amount of either, so price of gas, by the gas used, so used gas, not the gas, the maximum gas that you're willing to spend. Okay, so you will set, for example, let's suppose you try to deploy a contract. It costs 32,000 gas. You say, okay, the maximum amount of gas that I'm willing to spend is 50,000. I'm ready to pay for my gas 1 gigaway. Okay. Then sooner or later, a miner will confirm it and will ask you to pay 1 gigaway by not 50,000, which is the maximum, but the 32,000, which is the effective gas that deploying a contract costs. Okay. This is pretty important because every time we will do a transaction, it will ask you, well, let's make also a practical example. I don't have a transaction, but let's see. This is my wallet. Let's see if I'm able to log in. Yeah. If I want to send money to another account, okay, this costs for I think 21,000 gas. Okay, and this is how much I'm going to pay. Let's advanced options. Okay, can you see gas limit 21,000 because making a simple transaction costs 21,000. I can send more, 30,000. Okay, and this is the gas price in gigaway. I can send less. It will be confirmed in a longer time. I can send more. It will be confirmed in a short time. Okay, can you see if I set 56 minutes, I'm paying too low. Okay. Doesn't mean that I will spend 30,000 gas because making a transaction costs 21,000. So what the difference with respect to Bitcoin blockchain is that here you have 2 sort of fees which multiply themselves. How much gas do you use, which depends on the complexity of what you're trying to do, because you're not always just trying to do a transaction. Yeah, sometimes a transaction, sometimes other things, such as executing a program. But depends on the multiplication of what you're trying to do by the price of the gas. Remember that if the maximum amount of gas is too small, so for example, if now I try to make a transaction here, advanced options, putting a gas limit smaller than 21,000, the transaction will fail. I can't even do it because the wallet knows it. The transaction will fail, and I will pay the gas anyway. Okay, that's it. There is a website which may be useful. Ethgastation.info if you want further information on gas. Okay, recommended gas price. This is the recommended gas price to have the transaction confirmed fast. Okay, etc. Either gas station. Okay, as usual, we have either scan, as I told you before, either scan.io and etherchain.org are the two websites which let you look at the blockchain. However, since we use the test blockchain, which is rinkby.etherscan.io, will let you look at the test blockchain. Okay. I think we have said everything. The only thing to be added is that there are basically 3 operations you may do. No, let's say 4, but 3. One is deploying a contract. So you put a contract on the blockchain. Cost 32,000 gas, by the way. The other one is making a transaction to a contract. Transaction to a contract or to another person. To another person is a plain 21,000 gas, that's it. A transaction to a contract instead requires you can send some ether and some messages for how the contract should be activated, or 0 ether and some messages. So if you send some ether, the ether will go on the contract balance. Okay, if you send 0 ether, nothing will go on the contract balance. It's just a message for the contract to do something. Okay. Last thing you can do, you can make a call to a contract, which is different with respect to a transaction. We'll see it. A call does not use gas. Okay. You are just asking the contract for some information. So you don't modify the contract. You just ask him, let's give the contract personality, some information about its current state. For example, what's your balance, or what is the value of this variable, etc. Because the contract can have variables. Okay, so deploy a contract, put the contract on blockchain, transaction, either between your account and another externally owned account, or between your account and a contract. This last one can include some ether or not, doesn't matter, because even making a transaction with 0 ether makes sense, because you're sending anyway a message to the contract to do something. Okay, so you send a transaction with ether and parameters. The last thing you can make is a call, which is just an inquiry to your contract, tell me the value of this variable, and this is free. Miraculously, this is, for the moment, it's free. Okay, let's say some names. Ethereum is the name of the blockchain and of the network. Ethereum Rinkby in particular, the blockchain we use. Solidity is the programming language in which we will write the contract. So we'll write the contract in Solidity programming language. Okay. MetaMask is the wallet that we will use. You have seen it here. Here it is, the fox here. Don't ask me again for the password, please. Okay. I am filthy rich, as you can see. Unfortunately, only on the Rinkby test network. On the main Ethereum network, I have nothing. Okay. And finally, so Solidity is the programming language. Okay, MetaMask is the wallet that we are going to use. You can use any, while Solidity is the only programming language on the Ethereum blockchain, You can use any wallet. MetaMask is very nice, doesn't require anything, any installation, only a browser add-on. And finally, Remix is the interface to write Solidity programs. It's a very nice web interface, and this is the reason why I chosen it, because I don't require you to install anything to write Solidity programs. It's really very nice. You can just go here and write remix.ethereum.org. Okay. Poof. First, it even remembers the last thing I did. It's the last thing I did. It's a mirror. I don't know how does it do it. It's able to remember the last thing I did. Here, compile, run, analysis, testing. You can also use it to send transaction, and it perfectly interacts with MetaMask. So whenever you send a transaction, if you deploy a contract from here, it's able to take your money from your MetaMask account. So this is the reason why I've chosen it. It doesn't require any other program to be installed. It's simply a website, remix.ethereum.org. It's a web interface to write Solidity programs. There are other web interfaces, better ones, but it is simple. It's exactly what we can do. Okay, let me see whether we need something else. No, I think we have done everything. But the Solidity. Solidity, currently it's working on Rinkeby, on the fake Ethereum network. Okay, it's using my account. That's it. Let's see, I can stop the video. Goodbye.